Hi, everybody. We'll start in a few minutes.
Hello. Hello, how you doing?
Good, how are you?
I'm doing good, thank you. I'm ready to start.
In a few minutes, let's get everybody on real quick. I still have, it's like 3 minutes, so 6 on my computer. So while you are waiting, maybe open Canvas. Let me make sure that I have. Oh, I'm going to turn on the first module. So we'll wait like another minute. Please access Canvas and take a look at the syllabus, the first module. I'll go over that right now. And then if you want, you can take a look at Unit 1. So we're going to be doing a Unit 1 in-class assignment. And for those of you who just got on, I put in chat, this is my way of tracking attendance. And then I will update Canvas, of course. So if you can type in your full name in chat and your major, I'd like to know a little bit more about you. Okay, it's 6 o'clock on my computer, so I'm going to go ahead and get started. I see some familiar names from my online class and some of the students from my other classes in the last semester or two. My name is Casey Nguyen. A lot of people call me Dr. Nguyen. You can call me Mrs. Nguyen or Dr. Nguyen, it doesn't matter. I've been working for Mourinho Valley College for 3 years now. I teach in computer science and cybersecurity. I do a lot of activities to do outreach, and I work with Mourinho Valley Unified School District, Alberta District, Paris, and some of the local high school and middle school, or even elementary school to really promote technical education. I'm currently a STEM club advisor at Mourinho Valley College. As of last semester, we haven't started the club this semester. I'm also a Department of Defense Cascade internship advisor. Currently, I have a few students that are going through the internship with the Department of Defense. I'm working on an apprenticeship program for computer science and cybersecurity. Through this program, you can actually get working experience working for technical companies, IT company, software companies, or even organization that's hiring people that are in the technical field. So we are launching the apprenticeship course in spring. I will let you know a little bit further about course number under the work experience, so you can get paid while you're in that course. And I'm going to be the faculty that's running the course. So if you just join us, please type your full name in chat and put your major next to your name. I will add that into attendance after the course is done. Also, I will post Zoom recording. Speaking of that, I'm gonna make sure that I have okay. And then I use caption through YouTube. So I do share some YouTube video whenever I can. I try to make tutorial YouTube video. So I will put that into the module itself. What else do I want to tell you? Okay, right now, if you can access your Canvas and then take a look at your syllabus. So I have everybody on mute. If you have dire questions or if you just have questions in general, please unmute and ask. You can also hold down the space bar while you speak. That will unmute. Sometime when I'm in full screen, I cannot see chat. So if you have a question, just verbally ask, okay? So I'm gonna minimize the chat real quick. Okay, so I had posted the course information in CIS7. If you have taken my classes before, you probably are aware that I don't like to use very expensive textbook. This textbook can be purchased. So if you're using funding for textbook, you can actually make a purchase via Amazon or the bookstore. However, I found a PDF version of the book and I had posted it in the book on the textbook page. So if you haven't gotten a textbook, you can check it out there. Now, for our syllabus, if you look at the first module, basically, if you're new to Canvas, I posted some tutorial there. So if you want to know how to submit assignments and so forth, I think a lot of the students are familiar with Canvas now that we've been rolling online courses for a while since COVID. But in the second page, you will find information about the course. So we will meet every Tuesday and Thursday at 6 to 8. And basically on Tuesday, I go over the discrete math concept. And then on Thursday, after this week, we generally gonna program in C++ using the concept that we learned. So let's say that if we learn about probability, you will create a C++ program following the example that I provide. So I write all my labs. I don't use textbook lab. So you're gonna write the programs, you're gonna answer some questions while you're writing the program, and then that will be the lab activity. So the whole point is to correlate the mathematical concept and tie that into programming. And as many of you are in computer science, you will have to create programs to solve problems. And this is gonna help you really build the knowledge and the understanding on how to create programs, for example, programs for casino, for like the machines at the casino, or programs that for, you know, retail stores, how you're gonna be able to implement algorithm and so forth. So on Tuesday, we're going to talk about the math concept, and then on Thursday, we're going to tie that into C++ programming. The reason why I chose C++ because almost all students that are in either math or science or computer science have taken some form of C++ programming class like CIS7. So it's important to kind of choose the language that would be common for all the students, and so that way you don't have to learn from scratch. Now there will be part of the lab that's going to be a little bit more advanced than CIS7. So you might have to really kind of dive into C++ a little bit and try to understand it a little bit more. But I will explain the lab every single session if you log on to Zoom. So our learning objectives is to be able to implement real life situations, so that will come from our project, and then be able to add in the mathematical ideas and induction or recursion into the structure in our programming, and then to be able to create relevant recurrence equations. So the student learning objectives really talk a lot about recurrence, but we will have a whole chapter on it. And when we review, we will go over it. We will create programs that are going to be related to trees and graphs. And some of this you will see in CIS17C, which is data structure. And then we'll talk about binomial theorem, independent and Bayes theorem, and other mathematical theorems. So if you have taken discrete math, this is very similar to that. If you have not, this is going to be a good introductory for you to discrete math. Okay. So let me minimize this real quick. On the next page, list our class Zoom information. I don't use Confer Zoom. I gave up the license a while back when I was doing CyberCamp. So to acquire the license back, it takes a little bit of request. I like using my Zoom Pro. So this is the information that you use for our class meetings. And here's your syllabus. So as we kind of talk a little bit about what the course content is going to be like, so we're going to go over sets, functions, relations, some basic logic, graphs, tree, probability, and we are going to look at how we're going to implement that into a program, like creating a program for a blackjack game, or a program that's going to look at how we can map like people who are doing sales or delivering packages using some form of graphs. And so we're required to do 54 hours of lecture and 18 hours of lab. I like to add a little bit of lecture during our lab day, which is on Thursday. So you will have a better understanding of what you're going to be doing. Okay. So in on your syllabus, you would also see the course content. Sorry, my course content there. It lists all the principles and the topics. We'll go over sets, Venn diagram, relations. And then for this week, we are going to touch on binary number systems, doing a little bit of conversion. I see some of the students from my former CIS11, so this is mainly a review for them. But it's a good way that we can warm up the course. So we're going to be doing that this week. And then next week, we'll go into logic gates and truth table. It's important to understand that and how to be able to program it. So next week, we'll program a little bit using, bool and getting into a little bit of the gates logic. And we'll get into some of the proofs. I don't spend a lot of time, unlike a regular math class, I don't spend a lot of time going into some of the proof principle. I want to spend the time to really take the math concept and then tie it into how we would program or, discrete structure in general. And so we're going to get into counting, and we'll look at permutations, and then that will bring us into probability. We'll work a little bit on Fibonacci. Fibonacci is fun, looking at series and sequence as well. We'll talk about pigeonhole principle, Pascal, and some of the theorem. So this might sound very strange to you at first, but once we go over it, you're going to understand a little bit more on each of the theories about, and then we'll get into the programming side. Okay, graph tree, probability, I mentioned that already. And again, here is your student learning outcome. So by the end of the course, we want to be able to create a working C++ program that will incorporate some form of discrete math structure in our program, and we want to implement the algorithm within. Okay, now as far as IDE, I know many of you are taught to use Visual Studio. That's fine. For this course, for the sake of demonstration, I use Replit, so repl.it. And I have a lot of the example programs saved to the cloud so I can easily pull it, and you can use it. Simply just choose the language, and then if you create a user account, it will allow you to save your program on the cloud. And you can always download your CPP file, okay? So it's an online compiler. So you can choose any IDE of your choice. Now in Visual Studio, we got to make sure that we implement appropriate STL or the libraries accordingly. So when we're using that, right, I would have the program to show you how you would include different STL. Sometime we would use set, sometime we would use array, sometime, we would use math library. So we would incorporate that in our C++ program. Now this course is transferable to Cal State and UC. So that's why many of you are here, because you're on the ADT track to transfer. Okay. Now this book, I chose to use it mainly because it covers all the content that's required for the course. It's affordable. I can find a free version for my students. It's more of a workbook than a regular textbook, and it does have some solutions that's equipped to some of the questions. However, my assignments, I actually write my own assignments. So, and I will go over it every week. On Tuesday, we will go over the assignments together, so that way you will better understand the concept. Okay, so the link for your book download is also on the syllabus. For procedures, activities, and grading, everything I organize in my Canvas is module. So think of it like a unit. And every week we will hit a module. There will be time that we will have quizzes, or one quiz. There will be time that we will be, doing some discussion. There will be time that we will be working on certain assignments in lab. So all of these components are going to go into the module, and I tried to post a module earlier in the week. Sorry, I completely forgot. I forgot to turn it on this week, but however, I will turn on the next one earlier so you can preview. I do take late work. I take late work within 3 weeks. So the first week that it's late, that's 10% from your earned grade deducted. Second week that's late, 20% deducted from the earned grade. And the third week, I will take the third week, so that will be 30% deducted. But I will try not to take so far up late work, because I don't want a student to turn in week 1, 2, 3, 4, 5 near the end of the semester, because it's unfair to other students who've been working throughout the semester. So I try to make sure that there's fairness in the class. Credit should be earned where credit should go to where it's earned. So we want to make sure that that's fair for everybody. Now, in the circumstance that you have emergency that came up, and you can't complete, for a couple of weeks, make sure you communicate with me, and I will try to work with you. I'm very flexible, but in the case where you don't tell me, then I won't be able to take some late work that's so earlier in the earlier part of the semester. Okay. So for in-class assignment, we are going to try to complete it. So my whole goal in this class is to get you through the in-class assignment so you don't have so much work outside of this class. Okay, so we're going to try to do it in class while you're listening to me or watching Zoom. Then also in lab, doing lab, we're going to try to do that while we're in the session. And if you have, some stuff that you want to look at again or try to solve again, sure, that's fine. You can submit it later. So try to get everything completed so that way you don't have to worry about homework or doing it over the weekend. That will be too much because I understand that you have other courses like physics or math or English that you have to worry about. We will have a course project, and I will release a course project after week 10. It will give you different case scenario, and you will have to choose your course project to complete, and the course project is due at the end of the semester, so on final day. We will have a few quizzes throughout the semester. I don't do quiz every week. I rather you focus on the reading and understanding the material, and then, preparing for the next session. But we will have a few quizzes, and then we'll have one final exam. I don't do midterm exam. For the quizzes, you will have 3 attempts, and the highest earned score will be recorded. For the final exam, it will be password protected, and likely I will use lockdown browser. So if you have Chromebook, you might want to consider borrowing a laptop from Moreno Valley College or the campus that you're studying or that you registered to. They do have laptop program at Moreno Valley College, so you can borrow the laptop for the exam if you wish. It will work on iPad and MacBook, and of course Windows PC, but it won't work on Chromebook. No late exam will be granted. So if you have, things that are scheduled, or if you can't be available on the exam day because of work, make sure you let me know and I can open the exam a day before for you. So please communicate with me. For your grading, we have homework assignments, 15%, and we will mainly do homework assignments as review assignments. So before I give a quiz, I like to review for it, or before final exam, we'll have final reviews. And so your homework assignments will be mainly consist of, review work. So you will go back in the last couple of weeks and go over the material and answer the questions. Your quizzes will be 10% of your grade. Quizzes are multiple choice. In-class assignments and participation is 20% of your grade. And in-class assignments we will have every week. Participation would also consist of discussion, sometime, for attending class and asking questions. The lab activities will be 20% of your grade. Project is 15% of your grade. And exam is 20% of your grade. So that will altogether will be 100%. Okay. Now I use the standard grading scale. So as you can see here, right, in order to get through community college courses, you have to earn a C or higher. Anything below a C, you have to repeat the course. So let's try our best to get through the course and earn a good grade. For a student code of conduct, just be respectful of other people, avoid anything that would be offensive, and making sure, I just want to make sure that we have a diverse learning environment. So I abide by the college policy, and so that's stated in the catalog. And in case if you have complaints or any questions, you can look at the grievance policy, and you can file a complaint with Student Services and also Dean of Instructions. Attendance and participation. If a student doesn't show up or participated in 2 or more weeks, I normally would communicate with the student. But if I don't hear from you, I reserve the right to drop you from the course after the 3rd week. Now, sometimes, you know, a student would just do some work and then periodically drop into the class. And, you know, if it's past certain deadline, right, I would keep the student on and that student will get the earned grade. So if you have some challenges, you can't get through some of the assignments, you're having issues because you don't have internet, make sure you communicate with me. You can send me an email. You can send me a Canvas message. I know that they opened the campus now, so you know, you do have some access to some part of the campus, but make sure you communicate with me in any case, okay? Behavior issue, we touch a little bit on that with the code of conduct. Just be respectful. And for cheating policy, don't copy and paste your code. Especially for the course project, because I would know, right? It's okay that you look at somebody else's program and get an idea and be able to utilize that idea and write your own program. In technology, we improve on the existing idea. However, if you copy and paste your code, I have a way to find out. I have checker that I can use. And then I can also look at your code and I can tell whether you created that or not. So if you use some sources, make sure that you reference. But cheating policy is abide based on college policy. So if you committed if a student actually cheated on an assignment, exam, quiz, or any program that's submitted, that student will receive a 0, possibly being dismissed from the course, and then I will also report that student to the dean. So I really believe in giving credit where it's due, so make sure that we reference things, make sure that we don't take other people's program. And at UC, CSU, they take this a little bit more seriously, where they would actually terminate the student from the university. So just be careful and making sure that all your work that's turned in is your own, okay? Accessibility, if you need a special accommodation, make sure that you contact the SPS. The link is provided there, or you can call them if you can't, you know, if you want to talk to them. So if you need extra time on quizzes, exam, you have to communicate with them. They will provide a letter to me, and then based on that, I will accommodate based on what they recommend. My contact information is listed here. If you call this number, this is to my desk at Mourinho Valley College. It will send me your voicemail via email. The best way to reach me is through email. I'm very responsive in email, or Canvas message, because it will forward to my email account. So if I don't get back to you within the hour, the couple hours, I will try to get back to you within the day. So 24 hours is the responsive time. And my office hours, I hold Zoom office hours Monday, Wednesday at 11:30 to 1:30, Tuesday and Thursday 4 to 5. If you can't make these time, make sure that you schedule an appointment with me and give me some headroom, because I'm in a lot of different meetings, you know, and I also teach classes in the afternoons and also in the evening, also on Saturday. So I might not be available at the time that you need. So let me know, and then I'll work with you to schedule the appointment. Okay. And do we have any question as far as syllabus? Okay, so your textbook information you saw already, the PDF version is there. Here's some recommended resources. I also put in every module. If I find useful videos, I would put them into the module. So like for today, after we go over the binary material, and if you're still not clear, you can take a look at those videos, and so that way you can review and understand the concept better. Okay. There's some resources for Mourinho Valley campus. And then here's my contact information again. So this part is a course plan. This is basically plan out your weekly schedule. So if you're not sure what you're supposed to be doing, take a look at this and then go to the module. So you can click on module on the left of your canvas, and then it will list the modules. Now the later module will be closer to the bottom. So I listed all the activities that we're going to be doing each week, right? So you can have an idea of what we need to do. And then your final exam is going to be mid-December. In the prior week, if we can do it before, I would. We will see how the schedule is going to go, but I will do final review. So I actually hold, Q&A session and go over the questions with the students. So, and final exam will be 50 questions, multiple choice. If you have questions that you think would be useful for other students to know the answer, then you can post it here. And if you think you have the answer to those questions, you can also add your answer here. Periodically, I would go in here and I would post the answer or check out the questions that you post. But if you need immediate answer, the best way to get a hold of me is through Canvas inbox or through email. Okay, so with that, if you don't have any questions, we can start the first module or the first unit. So as I mentioned, tutorial videos is usually listed within the module, either under the to-dos list or on a separate page. So where do you find this? You can, if you click on module, right, the second module, this is what we're doing right now, okay? So I like for you to click on chapter 1 notes, right? I type out all the notes for the students so that way, you can add more to it if you want. And if you don't have Office 365, you can download Office 365. You get a free license. You can use the online version if you want, if you log into your account. And also, I need you to download Unit 1 in-class assignment. So let's have both of those open. Okay. So to start, we need to understand different number systems, right? And at the machine level, the computer only understands 0 and 1s. Now, when we create a program, when we write a program in C++, Java, Python, JavaScript, whatnot, right? Let's say that we wrote a program in C++, the compiler would take your entire program, right? Go through it, and what it does is it breaks it down to the instructions at the machine level, right? And those of you who took assembly, you understand that right before the machine level is the assembler level. So today what we're going to talk about is the binary numbers. And in binary, it's a base 2 because there are only 2 numbers in binary, 0 and 1s, and that's what the computer sees. So in this course, I want you to understand that the computer ultimately is a calculator. It is a calculator. So we instruct it to calculate or to compute, right? And so a lot of the times, if you have learned Python, or if you use like Python interpreter, or if you create a very simple program and you implemented math with it, you would see that it calculates, right? Now, when we program in C++, because it's strongly typed, we would have some kind of data type to declare our variable or our container, like array or vector. For example, we would say int, right, variable 1. to declare our variable called variable 1. Now, in that case, we would have integers, and these are referred to as positive integers or just integers in general. Okay. Now, integers, and in that data type, we can put different numbers, right? We can put, you know, whole numbers like 1, 2, 3, 4, 5. We can put 1,000. We can put 12. Now, that is considered unsigned integer. So whenever you see the word positive, right, in computer science, we refer to that as unsigned. And you do see this in some of the C++ program, where sometimes you would see programmer would have sign int, right, you know, as to saying that that's a negative integer, right, that they're working with. So when we're working with positive number, we would say that that would be unsigned. And since you were little, since you were a toddler, your parents had taught you, or an adult had taught you how to count 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And growing up, you learn math, and math is base 10. So we learn decimal number, and decimal number has chunks of 10. So like 0 through 9, that's 10 numbers in that set. And then we continue again, 11, 12, 13, 14, and so forth. So what we see in counting number that we've been using so far, that will be considered decimal number. Now, whenever you input an integer, right, like 125, the computer has to take that and it needs to break it down into 0 and 1s, and it needs to convert it. So today, what we're going to be doing is we are going to convert these numbers from decimal to binary, and then we're going to go in reverse. Okay? So, now, when you're looking at the number system, sometimes you would see like an octet system. That's for older computers, right? Legacy computers, you would see octet. That would be base 8. Or in the case where if it's a base 5, you would see this here. So technically, the proper way to really write out our counting number, the number that you've been learning since you were young, is really a base 10. So when you see the little 10 on the bottom, that's basically saying that what number system that you're using. And if we want to indicate binary, we would say a base 2, right? Like a little 2 notation on the bottom. So all that is just showing that this is the number system, the type of number system that we're using. Now that's different than the exponent, right? And so when you do a subscript like this, that will be the number system. And then when you do the superscript like this, that will be the exponent. Okay? So that kind of gives you a little bit of overview on different type of base, the type of number system that we're going to be working with. So in binary representation is a base 2. And we know that there are only 2 numbers, 0 or 1. 0 means it's off, signal is off. So from an electrical standpoint, because ultimately your computer, right, it consists of integrated circuits. So you would have zeros and then you would have 1. So 0 is for off and 1 is for on. Okay. Now, in the scale, what we would have is we would always start from 0 to the first power, which is 1. So anything that you raise to the 0 power, 2 to the 0 power, that will be 1. So when you have it to the 0 power, right, like I can have 100 to the 0 power, that will be 1, right? So we always start, the least significant number is on the right hand side. You always want to start from right to left, okay? So 2 to the 0 power, that's 1. 2 to the first, that's 2. 2 to the second, that's 4. And what do we notice when we're going from 1 to 2 to 4? And then the next one is 2 to the third is 8. We basically take 2 and we multiply it by the previous number. So for example, we start out with 1 on the right-hand side. Then if we take 2 times 1, we get 2, right? Hence 2 to the first. If we take 2 times 2 again, that gives you 4, 2 to the second. 2 times 2 again, that gives you 8, 2 to the third, and so forth. And this can continue forever, right? So this is considered the least significant bit, and it starts with the 1 equivalent in decimal. So when I have 1 as a decimal, right, that will be the bit equivalent. So now what I want you to do is go ahead and open your in-class assignment. We want to try something real quick. Okay, so let's take a look at this example very quick. So you always gonna have this equivalent scale in decimal. We start with the 1. We multiply that by 2. We get a 2, 2 to the first. We multiply 2 with 2 again. We get a 4. 4 times 2 gives us an 8. 8 times 2 gives us a 16. 16 times 2, 32. 32 times 2 again, 64, 128, 256, 512, 1024, and etc., right? So when you're looking at the scale right here, the least significant bit is on the right-hand side. And we're going to go from the first bit here, 1, 2, 3, 4, 5, 6, 7, 8. So if you go starting from this one, right, your 8th bit is located here. And we know that 8 bits is going to be equal to 1 byte, right? Or if we have half of a byte, 4 bits, it's going to be a nibble. So a nibble is equivalent to 4 bits, right? So if we're looking at only 4 bits, we're going to look at these 4 only, or these 4 only, right? And if we start with the least significant bit, the lowest number equivalent to the decimal, that will be on the right, the most right-hand side. The most significant bit will be the one on the left-hand side. Okay, so as we move to the left, as you notice, you multiply it by 2, your bit ranking is higher. So it's more significant over here because it's higher in value equivalent to the decimal, where it's lower in value equivalent to the decimal is on the right-hand side. Okay. Now, in that, what we're saying is, let's say that I have a variable that contains 14 as an integer. So for example, variable 1, right? I have int variable 1 equal to 14. I declare that in my C++ program. Now, how does the computer take that 14 and break it down into 0 and 1? Okay, so the first method that we're going to be learning is we are going to learn the subtraction method. It's very much like you have $14 in your pocket and you go to Target and you're trying to buy a few things within the $14. You don't have any more money, and that 14 is all you have. Okay, so you walk down the aisles and you can say, what is the most valuable item that I can get for $14, right? And so let's say that these are the item values, right? So when you walk down the aisles, you said, oh, there's a t-shirt for $8, so I can buy that t-shirt for $8. So what I want you to do is, when you look at the value that's given to you in decimal, and when you need to convert it to binary, you need to say, what's the highest number that I can subtract from the decimal equivalent scale? Okay, so when we start with 14, we say, oh, well, I can't subtract 16. That's higher. So that's gonna give me negative, right? Like, you have $14, you cannot buy anything That's $16. So we want to spend under 14. So we're going to take 14, we're going to subtract 8. Anytime that you subtract that number on the scale, you want to put a 1 on the top. Okay, so that means that that bit is on. Okay, so I took 14, subtract 8, I get a 6. Okay, we're not done. So we spent $8. We still have $6 left. Then I go down the list and I say, oh, I can subtract 4. That's the next number, right? So 6, because I have 6 remain here. 6 minus 4, I get a 2. So when you subtract 4, you put a 1 on the top. Okay. Now on the next one, I know that I have 2 left. So I can do 2 subtract 2. I get a 0 left. So if I subtract 2, I put a 1 on the top. So what does this mean? This bit is on, this bit is on, this bit is on, and the last bit is off, right? Because after I subtract 2, I only have a 0. If I cannot subtract 1, I put a 0 on the top. And as you notice, with an even number, we will never have the least significant bit on, okay? So let's say that if I have 15, right? 15 is going to give me 1, 1, 1, 1. Okay? Any question with that? No question? So the scale for the equivalence is always going to be the same. It's always going to be a multiple of 2. It's 2 to the power of n because it's binary. Okay? And the least significant bit is going to start on the right. The left is going to give you the most significant bit. So your LSB is on the right, your MSB is on the left. And you can use the subtraction method for the conversion. All you do is start out with the largest number that you can subtract from, get the remainder, keep subtracting until you cannot subtract anymore. Every time that you subtract, you put a 1 on the top. Okay? All right, so let's try the next one. Let me get the student version. Real quick, and I'll do it with you. So as some of you already probably got started on this. So we saw the example, right? Now we have 309. 309 in decimal, right? Like this is our integer, and we need to convert it to a binary, okay? So we know that 309, what we can do is we can take 309. We subtract the largest number on the scale is 256. So if we subtract it, we want to put a 1 there. 256. Okay. Now, you always want to start out with the largest number that you can subtract from the given number. Okay, so if I give you 109, right? You want to start here. Okay, so 309, we can subtract 256. Okay, so that's going to give me what? 53. Okay, now next, I'm going to skip 128 because 53 is way below 128. So we put a 0 there. Okay. 53 is also below 64. We cannot subtract it, so we put a 0 there. So the next number that we can subtract from is, from 53 is 32. So 53 minus 32. Okay, so if you subtract that number, don't forget to put a 1 at the top. Okay, so that's going to give me what? 21. Now 21, I can subtract the next number, which is 16. So if I do 21 minus 16, that's going to give me 5. So if I subtract 16, I put a 1 in the top. Okay. Now 5 is under 8, so we cannot subtract 8. Okay. I can take 5 and I can subtract 4, so 5, oops, sorry, minus 4, which gives me 1. So if I subtract 4, I'm going to go ahead and put 1 there. So 1 is below 2, the next number we can't subtract it, so 0, right? I have 1 that's left right here. We have to subtract it until we can't, we have 0 left, right? We need to spend all our money. We need to buy as many items as we can down that aisles, right? That we can afford under $309. Okay, so here we have 1 subtract 1 is gonna give me 0. Sorry. So here is our binary equivalence. So technically, if you write it out, right, 309 in decimal, I'm going to properly write it for you so you can see, is equal to, right, 1 0 0 1 1 0 1 0 1. And if you wanted to do it like how the textbook recommended, then we would have the subscript of 2. Okay. Any question? Okay. So what do we take away from this with the subtraction method? Again, when we have a decimal number, we wanted to look at the decimal equivalence that's under it, right? So that way, what we can subtract with. So what we're gonna use that 256 right here to subtract 309. So 309 subtract 256, and we would keep on going with our remainder until we get 0 left. And every time you subtract, you put a 1 on the top to indicate that bit at that place is on.
Professor, I had a question. So
Sure.
what about in the case where, will there ever be a case where you have a number greater? I mean, like you don't end up with 0, but like you have to have a repeat of. I guess you just don't end up with 0. That's my question.
We always end up with 0 in the conversion. The computer has to convert it, right? So let's say that, are you referring to fractional? Or fraction is a little different, but as far as the conversion, right, it's always we have to subtract it until we get back to 0, right? So let's say that I have an odd number, right? I can subtract it until I can't subtract it anymore. So let's say that I have, let's do the next one, right? A different number. I have a 94. So instead, starting out with a larger number, you know that you're going to start at 64 to subtract, right? 94 subtract 64, you get 30. 30 subtract 16, you're going to skip 32. You always going to subtract until you get a 0 left. Okay? There won't be a case that you have remainder in the subtraction method.
I have a quick question.
Sure.
Do you want us to show our work just like we did here?
Yeah, so if you want, you can type out your answer like this, right? But I prefer that I would see your work, and that's mainly for your purpose, to keep notes. So that way when you look back and you say, oh, this is what I did, right? So yeah, I'm not picky with, like I know some math professors, they want you to show every step. Okay, but the way I do it like this, so that way if you're new at this, it helps you understand it better.
Okay, thank you.
Mm-hmm.
Would it be an issue if you're used to adding rather than subtracting?
Yeah, so I will go over the addition method when we go in reverse.
Okay, so for showing work here, you would expect us to write the subtraction method then?
Yeah, so I want you to practice the subtraction method so you know. So let's say that down the line, right, you have to, will we ever manually do this However, no, not really, right? We wanted to do this so we can understand. But let's say down the line, if you need to explain this to someone else, you would know how to do it, right? You know, maybe one day you would consider become a professor and to be able to tell your students, right? Computing, you know, as concept hasn't changed very much. So this is, you know, ultimately we have to get back to the machine level. So, but yeah, we will not sit there and manually calculate everything out like this way. However, we have to understand the concept. So yeah, whether you're using subtraction or division method, it's up to you. But for this activity, I want you to show me how you can do it. Okay, that's important.
Oh, I meant addition, like just adding the numbers together, because there's like you can logic your way through like this sum cannot be 128 and 64 because it'd be higher than your amount.
Yeah, if that's how you think, I'm fine with that.
Okay.
Yeah, but I'm going to show the addition method when we go in reverse, when we go from binary to decimal. All right.
Professor?
Yes.
Sorry, I just have one question.
Yes.
I'm a bit confused on, I mean, I got the whole process, but how did you get the 10 and the 2 for the final answer?
Oh, okay. So when you write out binary, it's always going to be 0, 1s. Okay. So how do I get this number? I get this number from here, from the top.
Okay.
Okay.
And the 2 on the bottom?
And the base 2 just indicate that it's a base 2 number system. It's a binary.
Oh, okay.
Yeah. And then this little 10 right here just indicated that it's a decimal number, human counting number. Okay. Yeah. So, you know, that's a textbook way of saying it. But if you see 0 and 1s like this, you know that it's a binary. Okay. Yeah.
All
so
right.
the bases indicate number system. Good question.
Thank you.
I had one more question. So like the first one, you left the numbers blank. Do we have to I mean from 256 to 16, do we just leave it blank or can we just fill it in with zeros?
You can fill it in with 0 if you want. But see, now on the calculator, if you ever utilize calculator to convert, it's gonna forget all these 0 because null is nothing. Right? It's off, signal is off. So it's only going to care about, you know, where that bit actually starts. So yeah, you can fill in the 0 if you wish. If that's easier for you, you can leave it off if you want. I'm not particular with it. It's just whatever is easy for you to understand, that's fine with me. But yeah, technically leaving it off or putting the 0 there doesn't make a difference.
Thank you.
Okay, so if you got A, then try B. So complete B. And we would start with the same process. We start with the largest number on that scale that you can subtract from 94. And then with the remainder, you're going to keep on going until you get to 0. Okay. So we know that we would go from 94, we would subtract that guy, right? So when you subtract it, you put a 1 on the top. So 94 minus 64 gives you 30. You have 30 remainder, so we would take 30, subtract. We can't do 32, it's larger, so you put a 0. We're gonna have to subtract 16. So when you subtract 16, put a 1, and that gives you 15. I'm sorry, 14. It's toward the end of the day now, so my brain is a little bit leaky. 14, we have 14 remainder. We're gonna go ahead and subtract 8, right? So when you subtract that number, don't forget to put a 1. So that gives you 6. 6, we can subtract 4 and 2. So let me move this to the one page, okay? So that way we can see it together. Now, for some of you, if you're using like whiteboard and you scribble on your tablet, I don't mind if you handwrite stuff and save it as a document. If you put your notes on top, and that's fine. You can turn it in that way as long as you turn it in and I can see the answer. Okay, but I'm just doing this so we can all type together. So I can subtract 4 from 6 there. That gives me a 2. And then 2 minus 2, which gives me a 0. So as you can see, with an even number, that one is always off, right? 2 to 0 is always off. So if we have an odd number, that one is going to be on. So what's really our answer, right? Our answer are these guys right here. So it's 1 0 1 1 1 1 0, right? So technically our answer is technically our answer is 1 0 1 1 1 1 0 for binary. So 94 in decimal, the computer going to see 94 as that number 1 0 1 1 1 1 1 0. So for quiz and exam, you are expected to know how to do conversion, right? And then if you do take my assembly class, this is where I start as well, because in assembly you see a little bit more of the, binary and equivalence, especially when you're using like an emulator. Okay. Any question would be?
Yes, I got one question. It's no matter what kind of number we have to convert, we always going to use 1 to 256. That's
You can go higher than 256. Okay, let me see if I can. So you can even go to the left of this, you can go to 512, right? And then 512 times 2 again is 1024, right? Times 2 again. So in a very large number, you can continue to go. So because, let's be realistic, right? In today's world, right? With data, we don't see anything it's just in 1 byte. We have thousands of bytes, millions of bytes, right? Like for example, when you're looking at like video file, or when you're looking at image file, right? Those type of files so much larger than just 1 byte. So the reason why I chose to use less than 256 is just to show you, and it's easier for you to kind of practice. But let's say that if you have 3,000, right? Your scale will continue to keep on going. And how do you know? You just take that number, multiply it by 2 to get the next number, multiply it by 2 to get to the next number, and so forth. Okay?
okay. Thank you.
You're welcome. All right. Any other question? Okay, so let me not use the note thing anymore. Okay, so let's touch back on our notes here. Okay, so The book kind of give you the example on how to look at binary representation. Okay, and I put in a little bit of example for you there, kind of like what we just went over. Now, when you're going from binary back to decimal, so let's say that you're given zeros and ones, and you need to put it back into decimal format, base 10. You're going from base 2 to base 10. Then you would go in reverse. You would do the addition method. Okay. So in this example, what you see is, so this is given to us, right? And so when you write it out, it would look something like this. And beneath it, you would have the equivalent scale, right? So let's say for the test, you're not going to be given this, right? You just know that the most right-hand side that starts with the 1, 1 times 2 is 2, times 2, times 2, times 2, so forth. And it's going to keep on going, okay? Now, earlier, we went down and we started subtracting because we went from a decimal number to the binary. Now we're going to do the addition. What do I mean by this? We are only going to add the equivalence in decimal that has a 1 on the top. So we're going to add this guy, this number, right? This number together. So earlier I had a question that you were saying, well, you know, I wanted to make a sum that's going to be less than this. Technically, that's what you're doing, is you're looking at what could be the total value, right, in equivalence as in decimal. So when I have a 1 on the top, I would know that I would take that and add it. So I would add 2. 2 plus 4 is 6. 6 plus 16 is 22, right? 22 plus 32 is going to give me what? 54. Okay. So this binary tells us that it's 54 in decimal. So when you have an integer that's 54, the computer sees it as this. Okay. So the addition method, you simply just add the bottom scale value, the decimal equivalents up for all the bits that's on. Okay, so let me get back to here. Okay. I'm kind of jumping ahead, but let's see. So I want to come back to number 2, okay? Because I want to explain that in a little bit. So as I already talked about the addition method, let's look at number 3. We'll come back to 2. All right. So we saw that this is like the same as the example that's in your notes, right? You only add the bits that have the ones on top, okay? So now let's do question C3, okay? So what I'm going to do is I'm going to put these 0 and 1s on the top boxes here, starting from the right. Okay, I'm going to double check and make sure I have everything. Then I would then go ahead and add all the value that has the ones on the top. Okay, so what does that mean to me now is that I'm going to take 32 plus 8 plus 2 plus 1. That's going to give me 42, right? So when you have this binary value, that's going to give you 42 in decimal. So technically it's 42 base 10 with a little 10, right? And then these guys is, you know, 1s and 0s with the base 2. But we would say that this is 42 in decimal. And that would be your answer. Okay. Any question with the addition method? So you simply just place that onto the scale, add only the value that has the 1 on the top. This is 3C. Again, we can do the same thing with D. 1.
Did you mean to add 2 instead of 1?
Oh, yeah, I'm sorry. Thank you for catching that. That will be 42, 43. Short one. Sorry. Okay, so we have 4 ones in the over here, 2 zeros, and then a 1. Okay, so I'm doing D now. So you place the binary value here, and then what you're going to do is you're going to add these together to get the answer. So we ended up having for 3C as 64 plus 8 plus 4 plus 2 plus 1. Which gives us what? 74, 78, 79 in decimal. So this value in binary is going to give us 79 in decimal. Any question? Okay, so no questions. So we got the addition method, okay? So what does this mean, right? We're gonna have to know how to do this for our quiz and exam. You will be given decimal or binary value to do the conversion. Okay, next. I'm going to jump back to number 2, and I'm going to talk a little bit about the division method. So another way that we can go from decimal to binary is we divide. You learned the subtraction method earlier. This is a second way to solve the problem to convert using the division method. So it tells you that the first step is that you would start out with dividing by 2 because it's a base 2 number. Okay. Now, if you divide it wholly, right, and you don't have any remainder, you put a 0. That means that if it divides evenly and it doesn't have any remainder, right, then you would put a 0. But if it does have a remainder, then you would put a 1. Okay, so let's take a look at the example program. If you start out with 152, you divide it by 2, you get a 76. It just divides evenly. It doesn't have any remainder. There's no 1 left, right? Then you put a 0. It divides evenly. Then you take that 76 and you divide again. 76 divided by 2, because it's an even number, it divides evenly again. So that's going to give you 38, 0. 38 you take that and you divide it by 2 again. 38 divided by 2, you get 19, right? 19. Since 38 divided by 2, it's evenly, so we get a 0. There's nothing left, right? 19, we're going to go ahead and divide it by 2 again, right? This time, because it's an odd number, you're going to get a 1 remainder. So when you have that, you're going to put a 1. Okay. Then 9, you're going to take 9 divided by 2, which gives you 4 with the 1 remainder. Then you put a 1. 4, it's an even number. 4 divided by 2, you get a 2, 0 remainder. Nothing remains. It's an even number. 2 divided by 2, you get a 1 with 0 remainder. Again, that's an even number. We're not done, right? So we still have 1. 1 divided by 2, you get a 0 because it's still 1 remain, right? So that's going to be 1. Okay. So that when we write this out from a binary format, you're going to write it from bottom up, left to right. So it's going to become like this. Okay, so the 1 from the bottom goes to the left. That's going to become your most significant bit. And then the next 0 go next. And then the next 0 goes next, and so forth. Okay? So in the division method, what we're doing is we're going to start with the number that's given. We're going to divide it by 2. If it divides and it has no remainder, we're going to put a 0. If it divides and if it has 1 remainder, we put a 1. And when you write it out, it's from left to right, bottom up. Okay, so let's practice on our assignment. Let's go down to this is my, okay, I just want to double check with yours. Okay, so 1 second. Let's go back to number 2. So you have to take 185 and you need to use the division method to convert, right? So I'm going to do it with you so we would know. So for number 2, we're going to go 185. We're going to start it with divided by 2. It's going to give us what? 92. And then we have a remainder 1, right? I'm going to tab it. So let's see.
Isn't 185 the example problem?
Let me 1 second, okay? I'm using my drive, so let's see if your file matches up. It should be version 1.1. Yeah, you can use the one, but I want you to practice here, so write it out. So it's just like what we just talked about. Yeah, I showed you the example problem there. Okay. So I want to do it with you so that way we would know. Let me close my CIS, my Python class real quick. So that way we would know what to do. Okay. All right. So I take 185, I divide it by 2. I get a 92 because 18 divided by 2, I get a 9, right? And then 5 divided by 2, I get a 2 with the 1 remainder. I'm not done. So 92 again, because that's the quotient right here. We're going to take the quotient and we are going to divide it again. That's going to give me 46. And I don't have any remainder there, so that will be 0. Then 46 divided by 2, that's going to give me 23, remainder 0. 23 divided by 2, since it's an odd number, we are going to have a remainder, right? Let's put 11 with the 1 remainder. Then 11 divided by 2 is going to give you a 5 with the remainder 1. And then 5 divided by 2 is going to give you 2 with the remainder 1. Sorry, I had a typo there. And then 2 divided by 2 is going to give you a 1 with remainder 0. And then we're not done, right? 1 divided by 2 is going to give you a 0 with the remainder 1. Okay. So your answer, we're going to go from the bottom, which is this guy here, to the left. So we're going to do 1, 0, 1, 1, 1, 0, 0, 1. And that starts at the left, so you know. Okay, so that's the division method. We simply just divide it by 2. If there's 1 remainder, we put a 1. If there's no remainder, we put a 0. And once you get to the last part, so this last part represents the most significant bit. So that's on the left-hand side, bottom up, left to right.
So if the answer is 0 in the end, it's always a 1.
What do you mean? Oh, the answer is 0 at the end here?
Where you
Or
did 1 divided by 2.
Oh yeah, because if you think of like division, right? If you take 1 divided by 2, it's 0 time, and you have 1 that's left. Like long division. So if I take, because technically it's 0.5, but you take 1 divided by 2, right? Because 1 is less than 2, it's 0 time, and then that 1 is remain. So you're gonna have that 1 left.
Okay, thank you.
Yeah, so we want to get all the way down to the fraction of it, and that's, if that's the case, if you have a half here, you know that it's going to be a remainder 1. It's a 1 there.
Professor,
Sure.
just to make sure it's, so we always have to write it backwards then?
Yeah, for the division method, it's like this. I you know, from long ago until now, for many years, I learned better with subtraction and addition, but ultimately division is really subtraction in the back, right? But yeah, so it's easier for, in my mind, like I can quickly calculate with sum and subtraction, so that works better for me. But some people, they prefer the division method. But yes, you're always gonna go right from bottom up, left to right for this method.
Okay.
Yeah, there are different methods to do the conversion, but these are the most common ones. All right. Are we okay with this? Any other question?
Hello?
Yes.
Oh yeah. So is this the basically gives us the same results, but it's just a different approach
Yes.
to the previous? Okay.
Yes. Yes. You can do subtraction or division. You should still get the same answer. Okay. Now, like I said, we don't manually we don't manually do this, right? And as some of you already know, you can use the calculator to check. So for example, I'm on Windows 10, right? And I open my calculator. You guys see calculator here? Most of the time you see standard. Sometime when you take calculus classes, you would use scientific, right? Or trigonometry, right? But the programmer one gives you the options to do the calculation, right? So let's say that I wanted to use binary, right? Or then I click on the bin and it's only going to give me 0 or 1. But if it's decimal, right? Like earlier we did the 94. So you would select decimal number system, you type in 94, and then here is the answer for it. But using the calculator, I want to point out something that's essential, right? You notice that the size here is Q word, meaning it's quad word, right? And the word size, the way the window structure this, it's based on x86 with assembly, so it's 16-bit, right? So quad word means that it's gonna be storing for 64-bit. So even the number is small. So each of these, each of this ones and 0 here represent 1 bit, right? 1 bit, 1 bit, 1 bit, 1 bit, 1 bit, 1 bit, and so forth. So when this is stored with the quad word, what it is it's still going to represent 94. The rest is just not, it's just not on, right? All of these are 0 in the front. So it kind of zero out all of the other ones in the front here. Now I can change the size down to, let's say, double word. That will be 32-bit. That means that it's still the same answer. What happens is it's going to shrink that down to an allocation that's going to be less to hold that number. Okay, and then we can also do it again down to word, which is 16, and then down to the byte, which is 8. Okay, now you know, so most of the time when you open it up, it's always going to be quad word. Why is this important? Because let's say that I have it as byte, right? And for my decimal, I wanted to put 189. Okay. So you notice that it's not going to be able to store the third number because the computer only cut it down to 8 bits. So the maximum like 18, that's going to be 2 digits is going to be what it can hold for that byte. Okay. So as you get a larger, right, integer, you would see, and this kind of tie back to data type, as you can see in C++, like a larger number in the 1,000, we want to make sure that we allocate the proper size, right, for our container, like our variable. Okay, so that way I can punch in, you know, larger number. Okay, and that's going to give me the binary equivalence. Okay. All right, so that's how you use the calculator to check, right? And you would use the programmer mode. Now, Lockdown Browser doesn't allow this mode. It uses the scientific mode, but we'll talk about the test later on. We're not too worried about it, but I want you to know how to do this. This is important to me, and it's important for this class. I'm sorry? I didn't get your question. Did you have a question?
Sorry, no, that wasn't a question.
Okay. All right. So we got our conversion. Now let's talk about addition. And, you know, I encourage you, when you have time this weekend, you can take a look at those videos. There's some good videos on addition and subtraction in binary, right? So when we have like two numbers, let's say I have a number 4 and a number 6, right? I know that 4 plus 6 is going to give me a 10. Well, what does that 10 mean, right? So the computer is going to take that 4 and convert it to binary, right? And then it's going to take the 6 and convert it to binary, and it's going to add it. and then it's going to get a binary, and then it's going to convert that back to decimal. So when you use a calculator and you punch in your decimal number, let's say for your math class or for your accounting class, right? You type in the decimal number, the computer, the calculator on your computer, the computer is going to have to convert it to binary to do the addition. So here's the addition rule. When you have a 0 plus a 0, you get a 0. When you have a 1 plus a 0, you get a 1. When you have a 0 plus a 1, you get a 1. When you have a 1 plus a 1, it's a 0 with a carry 1. So that carry 1 jumps to the next place to the left. Very much like how you would add like 19 with 12, right? So a 9 plus a 2 gives you 11. So you put a 1 with the carry 1 to the next column. So when you do a carry, you bring this one to the left of it, and then you handle 2 number at a time. Okay, so here, let's take a look at this example. So I know that when I have a 0 plus a 1, I get a 1 here, right? Based on the rule. Okay, a 0 plus a 1, I get a 1. A 0 plus a 1, I get a 1. A 1 plus a 1, I get a 0 with a carry. Okay, bring it over here. Now, how do we do this carry? So you're going to handle 2 number at a time. So you are going to take 1 plus 0, right? Let me get my little drawing tool out here. So a 1 plus a 0 gives you a 1 here. Okay, you're going to do a 1 plus a 0, give you a 1. And a 1 plus a 0 gives you a 1. See that? So we're only going to handle 2 number at a time. Okay? So that's how we get out that one right there. Okay? Now you have a 0 plus a 0, you get a 0. A 0 plus a 0 is a 0. A 0 plus a 0 is a 0. A 0 plus a 0 is a 0. Okay? So when you have the 1 plus a 1, that carry 1 gets moved to the left of it, and then you handle 2 number at a time. Sometimes you get a 1 and a 1, right? You get a 1 carry and then a 1 and a 1 with a 1 carry. So it does get a little bit more complicated. Okay. Any question? So this is how we handle addition method. Now on the next part, what we're going to be doing is this one. Okay, number 4. So what you're going to do is you're going to take this one. So I'm going to type out the answer there for you. So we want to start with the right-hand side. Sorry, let me get the format right here. So we have a 1 with a 1. We know that it's a 0 with a carry 1. Okay, with that carry 1 here. So a 1 with the 0. Then you have 1 with the 0 is a 1. A 1 with the 1, we have a 1 here with the carry 1. I want to put that there so I can see. So 101, what's okay. Then 1 with the 1 is a 0 with the carry 1. 1 with the 0, 1 plus a 0 is a 1. 1 plus a 1 is a 0 with the carry 1. 1 plus a 1 is a 0 with the carry 1. 0 with the 1 is a 1. I'm trying to line it up, so let's see. Okay. So as you continue this, you got to make sure that the one that's carry get brought to the left-hand side. Okay. So when we start with the right, 1 with the 1 is a 0, carry 1. 1 plus 0 is a 1. 1 plus 1 is a 0 with a carry 1. 1 plus 1 is a 0 with a carry 1. Sorry, trying to work with Microsoft Word is not as easy as writing on the whiteboard. I know I have whiteboard in Zoom, but okay. And then, where was I? Yeah, with the carry 1, 1 0 1 1, and then 1 with the 1 is a 0 with the carry 1. 0 with the 0 is a 0. Let me double check. 1 0 1 1 0 carry 1 1 0 1 carry 1 1 0. Here's a 0. Okay, and then that becomes 1 1 1 and 1 in the front.
Professor, could you write it down because I'm getting confused too.
Okay. Yeah, let me see. Okay, so let me create notes here. You guys see that okay? All right, so we have a 1 1 0 1 0 1 1 0 1 plus 0 1 0 1 0 1 1. Okay, so we start with the right. So 1 with the 1, we know that 1 with the 1 is a 0 with a carry 1, right? So now what we're going to do is we are going to handle these two first. Okay, so a 1 with the 0 is a 1, right? When you plus that, it's a 1. A 1 plus a 1 here is a 0 with a carry 1. Oops, sorry. Didn't mean to carry it like that. The carry 1. Here. Okay. So what we have is we have 0 on the second one, right? Let me move that one over here so you can see. Now a 1 with the 1 is a 0 with the carry 1. A 0 with the 1 is a 1. Okay, so first we got this, gives us the 0 here. A 0 with the 1 is a 1 here. Okay. Now a 1 plus a 1, because we had the carry 1, is a 0 with the carry 1. A 0 with the 0 is a 0. Okay. Now we have this carry 1 with the 0. We're going to handle that next. That a 1 with the 0 is a 1. A 1 plus a 1 is a 0 with the carry 1. Okay. And then a 1 with the 1 is a 0 with the carry 1. 0 with the 0 is a 0. A 1 with the 0 is a 1. A 1 with the 1 is a 0 and a carry 1. 1 with the 1 is a 0 with the carry 1. 0 with the 0 is a 0. And this one just dropped now because ultimately this is 0. Okay. Sorry, my chicken scratched. Is that okay? You want me to repeat it?
No, this was helpful. Thank you.
Yeah, so we want to do 2 at a time, right? Whenever you carry, you put it to the next column, and then you just do 2 at a time. So this process is a lot easier when you handwrite it out. When I teach this in class, I use the whiteboard and I showed this. And yes, you can use Zoom whiteboard, but I use my Samsung Note. So, okay. So ultimately, let me put that back there so you guys can see. So you can go through and you can practice your addition. I think a lot of the students have challenges with addition and subtraction because the carry and the borrow. So sometimes it gets a little bit confusing when you have 1, 1 and then carry to the next line and then 1, 1 again, carry to the next line. Okay, let's do another one. Okay, so. All right, so I'm going to try to do a little bit better this time. So we have 0, 0, 1, 1, 0, 1, 0, 1. And we have 1, 1, 1, 1. So 4, 1, 0, 1, 1. Wait, I'm missing 1, 0. That was 0 and a 1. Okay, so we're gonna add these 2 together. So we start with the right here. We're gonna go from 1 with the 1 is a 0, And we're gonna carry the 1 over here. Oops. And then what we're gonna do is we are going to handle these. So 1 with the 0 is a 1. A 1 with a 1 is a 0. And a carry 1. So now we're gonna handle these two. A 1 with the 1 is a 0. And a 0 with a 1 is a 1. We're done with the carry. There's no more carry, right? We took care of the carry. Then we get 0 plus a 1 is just a 1. A 1 plus a 0 is a 1. A 1 plus a 1 is a 0. Now we have a carry again. Then we handle 2 first at the top. A 1 with the 0 is a 1. A 1 with the 0 is a 1. Took care of that carry. A 0 with a 1 is a 1. So that's your answer. Okay, any question?
Professor, I got a different answer. I think on the third column, you should get, you forgot to carry the 1 onto the fourth column.
Oh yeah, right here. I see what you're
The
saying.
answer is different, yeah.
I just saw that. Hold on.
Okay.
So this too. Hold on. Thank you. Yeah, as you were speaking, I was like, oh, I see it. Okay, so that's a 1. And then this one is a 0 with a 1. This one is a 0 with a 1. This one should be, oh, a 0, right? And then this one is a 0 with a, okay. So this one should be a 0 with a carry 1. This one is a 1, 1, 1, 1. I think that's it. Okay, let's check. 0, 1, 0. I think that's it. Okay. So yeah, I forgot the next column of the 1 when I did the 1, 1 right here to bring it over here. And actually from here to here, and then from there it changes over here. Okay, so we're coming down to the last 15 minutes and I like to hit subtraction rule. So similar to addition, you would apply subtraction rule when you subtract one binary with another. So when you do 0 subtract 0, you get a 0. 1 subtract 1, you get a 0. 1 subtract 0, you get a 1. Very similar to decimal, right? And then when you subtract 0, 0 subtract 1, you get a 1 with the borrow. You borrow from the next column, okay? So let me bring this down to the next page. As you can see that. So we are to do the subtraction here, and you would start from the right-hand side, just like how you did with the addition, okay? And right away, you would see that it would be borrowing right away from the left, okay? So let me get my notes.
Professor, on that one, the top number is smaller than the bottom one. Did you intend that to be the case?
Yes.
Okay.
Well, yeah, you have to borrow when it's the top is smaller. Yes.
Okay.
So let's try this together. Okay. So we have 1, 0, 1, 1, 1, 1, and a 0. And then here we have 1, 1, 0, 0, 1, 0, 1. Okay, so we're going to operate this subtraction, and right away, right, we know that we have to borrow from the left. Okay, so you have when you subtract 0 minus 1, you get a 1 with a borrow 1. So here we're going to have 1, and we're going to borrow the 1. Okay, and just like the other one, we're going to handle 2 at a time. Okay, so 1 with the minus 1 is a 0. 0 minus a 0 is a 0, right? A 1 minus a 1 is a 0. A 1 minus a 0, right? You saw the rule here, is a 1. Here is the same. 1 minus a 0 is a 1. 0 minus a 1, again, we have a 1 with a borrow 1. A 1 minus a 1 is a 0, right? Now, a 0 minus a 1, again, we have a 1 with the borrow 1. And this borrow 1 drop down. So similar to the addition, you're still going to lean into the left of it. And as you do that, you would operate 2 numbers at a time, like what we did here, right? To get this 0. And then we take 0, subtract 0, we get a 0. Now, as we talk about this, we have to bring up a thing called unsigned number and signed number. Earlier, we talked about unsigned as positive, and as you probably know now, that signed number means negative, right? So with this, what happens is, okay, so I'm going to use my calculator so you can see. So let's say that I have a negative 25 decimal, okay? Look at the binary that it's giving me. So the computer, it uses the ones in the front to really indicate that it's a negative number, okay? So as a double word, a 32-bit here, it's just going to fill out the rest of the ones to show you that this is a negative number. It's a negative 25. Because when you do the conversion, 25 really is indicated here. And then we'll do the 2 complement. This is a 2 complement of a certain value. So when you say a negative number, it's really a 2 complement of the unsigned number. Okay, so as we were talking about subtraction, right? So let's say that I take the number 13 and I subtract the number 16. We know that it should get a negative 3, right? And when you look at that, right? Now, if you say, well, Dr. Nguyen, isn't this part right here represent -3? Not really, right? It's a 2 complement of a value. So a negative number doesn't convert evenly like what we've been learning. It's number one, it's going to fill in all the ones in the front, and we have multiple steps. We have to flip the bits and add the 1 to really represent a negative number. It's the 2 complement. Okay, so in this sense, going back to the problem we just did, what will happen is, because it's a negative number, technically it would have all the ones in the front, you know, imaginary ones in the front to show that it's a negative number. Okay, so that's why you see this one sticking out like a sore thumb, is because you know that when it's subtracted, it actually becomes the negative. Okay, because the lower number is actually higher than the upper number there. Okay, so do I have time to touch on 2 complement? So I want you to complete, we just complete this one. You're gonna go ahead and complete B, practice, okay? There's a good tutorial video that I put on the page, so make sure you check it out if you're still confused, right? But what I would do is get a piece of paper and just do it, right? And so you would start with the right, you borrow, you handle 2 numbers at a time, and as you go down from right to left, that's gonna get subtracted. And so there you have it. Okay, and you can use your calculator to check. Okay, so we have like a few minutes left. Do you have any question for me? I'm going to change the due date for this, so it won't be due today. I always do that because sometimes, you know, ideally I would get everybody completed. Yes, you can turn it in today if you already completed, for those students already learned this before. But if you still want to practice, I'm going to open it, you know, I'm going to make it due on our next session, which is on Thursday. So if you don't complete it tonight, you can turn it in on Thursday. And, you know, if for the students that turn it in like the next night or a few hours late, I don't really ding 10% or, you know, for late. But if it becomes like, you know, 5, 6, 7 days late, then it's late. So if you want to spend a little bit of time to look it over and redo it and look over the notes and practice, you can. Okay. So unlike the other weeks, the first week, I want to spend a little bit more on conversion and going through the number system. So on Thursday, we're going to finish the rest of the lecture and we're going to do hexadecimal conversion. We're going to do the 2's complement. And so we will wrap that up for the week. But in week 2, on Thursday, we will program. Okay, and you can use your Visual Studio on your computer, or you can use any IDE of your choice, or even online compiler. Not a problem with me. Okay. Well, thank you for attending the first session. And if you have any questions or if you need help, please let me know. And then I will see you here again on Thursday. Make sure if you didn't type in your name in the chat, make sure you do so. Input your name and your major so that way I can go over, I look over the chat after we end the session. All right.
Where do we submit the assignment to you at?
You submit it on Canvas. I will show you that right now. Are you familiar with Canvas? So
Yes.
Here's your assignments, right? Yours look a little bit different. You have a submit button at the top. Just click submit and then attach the file that has the answer. Don't forget, you guys, I have quite a few students that send me like blank files because they forgot to save or they saved the wrong file. So I just get my same assignment that I gave back. So make sure that you have the answer on the document and then upload it. I use Windows PC, so I prefer to get docx or PDF. So if you're using Apple system or if you type stuff out in Google Doc, right, just convert it to PDF for me and then upload it. You know, so that way it's just easier for me to grade. This class has 36 students, and I think a few more are trying to add. So it's a little bit of grading, but it's not too large. I have had larger classes. Okay. All right. So we just have a few more minutes left. If you don't have any questions, then have a wonderful night. But I'm teaching Python, so if you are still interested, that class is still pretty small. It's a fun class to do. I'm also doing some cybersecurity class, which is computer forensic, which is super fun. But if you're looking to get Python credit for Cal State and UC, it's not in the system yet because when we got it approved, it's already past the February deadline last year. So they said, I work with the articulation officer. We got it approved for UCI, and we're working on UCR and a couple of other Cal State. But they said that you can bring in your transcript and they will articulate it manually with you when you transfer. So Introduction to Python is also a good class to take. Okay. All right. Have a wonderful night. You can sign off, and I'll see you here Thursday. Bye, everybody.
All right, thank you.
Thank you,
You're
Professor.
welcome. You're welcome. Have a good night.
If wait, Professor,
Yeah,
may I ask a question?
sure.
For the subtraction binary problems,
Uh-huh.
when it's when the remainder is over a 0, will it just be -1 plus 0 and then go on to the second number?
Can you share your screen with me? I'm gonna unshare real quick so that way I can let you share. So who just asked the question?
That
I
was
see.
Manuel. My name is Manuel.
Oh, okay. Hold on. Let me click you, and I will give you the permission to do that. Okay.
Okay.
I think. Okay, I think you can share now. Go ahead and share your screen and point to me which one you're asking. Click on the share screen button on the bottom.
Okay.
Okay, yeah,
me see.
so, So are you
Okay.
asking about B?
Yes.
Okay.
So, give me 1 second. Let me just see where I was. Okay, so I have to subtract the 0 from the 1, and then I get the remainder
Yeah,
on
so,
the on the left, and then I subtract, and then that gets me a 0, right?
Yeah, so the rule is that you do a 0 subtract 1, you get a 1, a 1 with the, I'm sorry, let me go back to the rule here, with the carry. So you have to carry it to the left.
Okay, and then when that carry is over a 0,
Yeah,
so
you borrow from the left. So when so a 0 minus 1, you get a 1, and then that 1 gets carried to the left column.
Okay.
And then you take that 1, subtract the top 1, then you get a 0.
So if that left column, the top one is a 0, it'll turn into a 0? If that makes any sense, because that's the part that I'm confused about.
Okay. Go ahead and unshare your screen for me.
Yeah.
Okay. I'm gonna write that out for you, okay? Hold on 1 second. Let me get my stylus. Okay, so I'll share screen with you so you can see. Let me open that problem up. So you're doing B, right?
Yes.
Okay, so it's 1 1, 1, 0, 0, 1, 0. And then it's 1, 0, 0, 1, 1, 1, 1. So when we subtract it, we know that we start right here. So what we're going to do is 0 minus 1. The rule is that it says that it's 1 with the borrow 1. See that? So we would do a 1 with the borrow 1.
Okay.
Okay, and then we take this, we subtract. So we're going to handle the top first. Okay. So a 1 minus a 1 is a 0 here. The little 0, I call it. But now you have this little 0 and the 1. So next, you're going to handle these two. Okay. So again, we have it less. So what happens here is it's going to be a 1 with a borrow again, right?
Okay.
Yeah. And then a 1 minus a 0 is a 1 in the middle.
Oh, okay. See, that's the only part where I was confused.
Okay. So when you subtract this, right, and then a 1 minus a 1, you get a 0.
Okay.
Okay. And then you can, and it looks it's the same. So this is going to borrow again. So when you write the borrow, then handle that borrow with the top number. And then you get that little number, the middle number, and then that middle number with the bottom number. I don't know if that makes sense to you.
Yeah.
So the borrow with the top, the middle with the bottom. Yes.
Okay. Yeah, no, that makes perfect sense. Thank you.
Yeah, yeah. So the middle number is the result from the borrow and the top, and the middle is going to get handled with the bottom to get your output. Yes.
Okay. Thank you.
You're welcome. Any other questions?
No,
Okay.
that was it for me.
Yeah. Can you hear me? I'm not.
Yes, yes.
Okay,
yes.
cool. The assignment, when we can turn in the same document, right? Or we can't?
Yeah, I you know, that's better for you. I normally have students just type in the same document. You don't have to have a separate answer sheet. No, just same document is fine.
Okay, thank you.
Okay, yep.
All right.
Any other questions?
I was interested in the Python class, and I was going to ask you for an add code.
1 second. Let me get out of screen share here. Oops. Okay. Who just asked me that? Melissa?
Yes.
Okay. Let me send you a direct message right now. I'm going to open my file and then I'll give you the add code right now. It's in the afternoon though. I don't know if it's going to fit your schedule, but we just went over installing Python. So tomorrow we're just going to write Symbol Lab to like print, but you can take a look at my notes. And I had recorded Zoom video on the module once you get added to the class. But we plan to do fun stuff with the class. So yes, I will give you the add code right now before you get off.
All right, thank you.
There you go. Okay. Any other questions? Okay, if you don't have any question, have a wonderful night, and I will see you here Thursday. Okay. Okay, take care, everybody. Bye-bye. Bye, Eric.